First of all, very, very quickly, let's take a look at rigid motion in a plane. And I'm going to go a little faster than I did the last couple periods so we get down to the lab. Now, rigid, rather than ask you what it means, we all have an idea. I'm just going to tell you. Rigid is what you think it is, right? Rigid is sort of the opposite of flexible. If you think about something or someone who is rigid, that thing or person is unbending, right? Unswerving. They're going to be, the person would be by the book completely. Follow the rules, no room for deviations, everything is organized and neat and tidy and all that, right? With an object, a rigid object would be one that is not deformable or flexible. You can't bend it. It stays in the same shape. Flexible would be the opposite. A flexible person would be someone who's easygoing, and a flexible object you could twist and you could contort it and deform it. So we're talking about not flexible motion, but rigid motion in a plane. That's what we're looking at in Chapter 7. And so, figures in a plane, what kinds of transformations could we do that would be rigid? Well, we can reflect, rotate, and translate. We're always going to start, and here's the vocabulary. This is mainly just a vocabulary introduction today. We're always going to start with something called the pre-image. Eric, put that away, please. We're going to start with something called the pre-image, and then the pre means before, and then we're going to end up with the image. AJ, why don't you grab your stuff and get out. So start with the pre-image, end with the image, and it's always going to be that way. Okay, so for example, we'll look at a couple situations here in the slideshow where we might have, like, say we got triangle ABC. Triangle ABC would be, that's what we're starting with, so that's the pre-image. And we're going to do something to it. We're going to transform it and turn that into an image. Now, the math word we use is maps. We can map a pre-image onto an image with one of these operations: reflecting, rotating, translating. So those are the three basic transformations: reflecting, rotating, translating. But we can combine them too. We could do a combination of, all the above if we wanted to. Okay. Now, for the purpose of just this quick introduction, we're going to say that the pre-images are always going to be blue. We're going to start blue, and the images will be red. So we're going to end up red. Okay. So, for example, here are three examples of blue pre-images and red images with the three different kinds of transformations. Here's a reflection, here's a rotation, here's a translation. Now, how do you think about this stuff? It's very simple. You can just kind of build a mental picture, and you're not going to have any trouble with this at all. Reflection in a line, we have to have some line that we're reflecting about, or reflecting in, we'd say in geometry. That's like, the line would be like a mirror. You were reflecting stuff in a mirror, or maybe even better, think about it as folding a piece of paper. So I could draw the blue pre-image in wet ink. I could fold the paper along the line, that's the line of reflection, and I could create the red imprint of that wet ink on the other side, right? That's a reflection, just like you already thought about it that way, I'm sure. Rotation, same kind of a deal. I could draw the blue pre-image on a piece of paper. I could put a tack in the paper. Okay, and that's what we call the center, right? And then we're going to rotate it about that tack, and that's a rotation. Okay, that make sense? No big deal. Translation, the most obvious and intuitive one. That's where we're going to draw a blue pre-image on a piece of paper, and to translate means to slide the image. Okay, so we're just going to translate the image to the right, and the pre-image, and then we get the red image over here, okay? So now, a lot of these transformations involve labels, like for vertices, for example. If we start off with triangle ABC as our pre-image, well, we're going to do something to that. Say that we reflect it, and we create an image of that original triangle. What do we call the vertices? We just put a prime next to them, and that's important because prime means changed in math, and it works all the way up through calculus and beyond. If we start with something, we do something to change it or transform it mathematically, then the result, a lot of times, we'll just put a prime next to it. Okay? And so what used to be in the pre-image, vertex A, in the image becomes A prime because they're related. Okay? So in this case right here, look, A maps over to A prime, C maps to C prime, and B maps to B prime. What kind of a transformation is that one? Yeah, it's a reflection, isn't it? At first, it might, if you don't look closely, it might even look like a translation, but it's not. If it were a translation, if I were to slide to the right, for example, to get the red image from the blue pre-image, then A would give us an A prime right there, wouldn't it? But it doesn't. It's clear over here. So it's been reflected over the y-axis, hasn't it? Right? Okay, transformation is reflection in the y-axis. The coordinates of the image we'd call A prime, B prime, C prime, because they come from the ABC. Okay, are they congruent? They seem congruent, don't they? Same size and shape. Doesn't that make sense that if it's a rigid transformation like that, if the whole thing is being reflected, it's not being warped at all. It's staying the same shape and size. So doesn't it kind of just makes intuitive sense there that these would be congruent? We could prove it if we wanted to. We could do a triangle proof here. We won't take the time right now. Our shortcut terminology for this, for that big long word, rigid transformation, is isometry. That's what we call these things, isometries in math. And you can probably tell me why. If we break down this word isometry into its roots, what do those roots mean? What does iso mean? We've said that before. It's iso. Like isosceles, for example. What's the iso part of isosceles? Okay, same. I have at least two sides of the triangle that are congruent, that are the same, right? So iso means same. If you were to look at a map of, like a weather map that had, what would it have? Like, what do they call those things? Isobaric maps, because they have all these little circles that show places where the pressures are the same. Right? It means same pressure, isobaric. We could think of all kinds of examples like that, but iso means same. What does metry mean, do you suppose? Say it again? Measure, yeah, it means measure. So same measures is literally what that means. So an isometry is a transformation that produces the same measures. So it preserves lengths, it preserves angle measurements, okay, preserves parallelism, distances, all that stuff. Everything, all the measurements are preserved in that rigid transformation or that isometry. So then real quick, just take a glance at a couple examples. Does that seem to be an isometry? Yeah, it looks like an isometry. Doesn't everything seem the same? All the measurements seem the same? What kind of isometry do you suppose that is? Looks like a reflection. Good. Okay. How about that? Not so much, huh? The red looks like it's a little different than the blue. Looks a little smaller, maybe a little bit deformed. So that's not an isometry. How about that one? Yeah, it looks good. Rotation. Okay, that's an isometry. Good. How about that one? Yeah, translation. Good. Okay, now this, by the way, this is a good symbol. Okay, this arrow notation. This really is meaningful to us. It literally says we're starting with triangle ABC and we're transforming it to triangle DEF. So that is math notation that we really do use, that arrow. The arrow means transform. Okay? I'm not going to get into the details because I want you to figure that out on your own. So that's our introduction. It was brief. Okay? But now I want to show you something I think that's very cool. I think you're going to really like this. We're going to do, I think you'll enjoy working with this program. So here's the assignment we're going to do. If you go to geometry, here's where you find this thing. I'll tell you what I'll even do. Oh, this is cool. Oh gosh, I'm just having all kinds of brainstorms. Okay, if I go to this assignment here, the 7.2 Sketchpad assignment, you open that up, here's what you see. This is a different kind of assignment than what you're used to. This one doesn't have things that you can submit and get graded right away. It's an essay. It's called an essay. I don't mean for this to be an essay, but it's called an essay type assignment. So these are essay questions. So what you'll do is you'll write your answers in this text box down here. And I actually have this thing set up so I'm using this new question type that I'm using on my textbook that I'm doing. And you can go in and you can, if you click on that little square root symbol, you can pull up this editor that's got all kinds of cool stuff, these math symbols that you can use. So I can do things like, I can do fractions, I can do square roots, I can do lots of stuff, exponents, right? I can do symbols, all kinds of math symbols. I can even do things later on. I can do limits and you know, integrals and derivatives and all kinds of calculus stuff too. There's all kinds of things. I can do matrices, okay? So lots of stuff. I'm not saying you're gonna have to do a lot of those today, but in the future you'll have that opportunity. So you're gonna write your stuff in here, and you can even drag over screenshots, okay? So how do you do a screenshot? Before I forget, because I forgot last period. If I want to do a screenshot, or you want to do a screenshot, if you have Windows 7, that's what the new labs here have, is Windows 7. All you have to do, and you might have it at home too, all you have to do is go down to the Start menu, go to All Programs, and then Accessories. And in Accessories, you'll see something called the Snipping tool. And you know, this actually, I think this is in Vista too. I don't know if it's in XP or not, but now that I think about it, I think I've got this at home too, in Vista. So if you click on Snipping tool, then it pulls up this program, and notice how it kind of whites out the screen. So you can drag in whatever frame you want to capture. So let's say I wanted to capture just this part right here. See, I can do that. And then there's my screenshot, and then I can save this thing wherever I want to. So what I would recommend you guys do is you just save this, maybe make a folder in your pictures folder, within your pictures folder, a subfolder, and just call it like Moodle Pics or something. And then you can just save it there. And then once you've saved it there, you can drag it over to, so pretend I did that. Then you can just drag the file over right here. You can drag and drop the file into that little Dropbox in the assignment. Or if you want to, you can just go up and navigate manually. You can say add a file, and then you can just go find it, you know, use the chooser and just go find it on the, wherever, on your computer. Okay? Does that make sense? I'm sure you've done stuff like that. Okay? So that's how you do that part. Now, what I'm going to try to do here real quick, I think I can even add Geometer Sketchpad right in this, I bet. Ooh, that would be cool. Let me see if I can. I bet I know what I can do. Oh, I know what I can do. Ha. Okay, let me do this. Oh, yeah, this will be cool. This will work. Okay, if I go. Let's try this. I think this will work. Oh, and here's where you go to find it, by the way. You go to Computer. So I'll go Computer. You go to Shared Files, PHS, Camera, Oya. And there it is. Okay, yeah, and I think that's going to work because it comes up as an executable. So I think that'll even work just like that. Okay. So maybe you don't even have to go through that. I think it'll just show up. I think it'll just show up right on here. Try that. Oops. Try it. See if that, maybe that'll work. Maybe you can just click on that and it'll open up. Okay. Let's go to, oh, where do we go? Oh, hang on a second. I didn't show you the document. Sit down one more second. Sorry. I forgot to show you Geometer Sketchpad. Sorry about that. Sorry. I got so excited I got a little flustered there. Okay, so here's the assignment. Everybody take a look, please. Let me quickly remind you how to use this program, because you probably didn't get that much of it when I showed you last time. It's very simple, though. So let's do the first part of this together, and then you can go in there and do it on your own. It'll be good practice. So I want you to do this assignment here. It says build a line. So create 2 points and then use construct. So let's just I'll take you through the basics of this. You don't need very much information, though. It's very simple and self-explanatory. this is, so we got a sketch right here. Anytime you want to start a new one, you go up to File and just do New Sketch. And so this is a sketch that we're doing. These are the tools that you have access to in the upper left. You get the pointing tool, which allows you to point to stuff and highlight it and things like that. And then you get the construction tools. You get the point tool, I mean the create a point tool, right? This is just, what do they call this one? This is the, what do they call this thing if I go to it? Doesn't even give it a name. Well, I don't know what it is. It's the selection tool, arrow tool, I guess. So there's the point tool for creating points. There's the segment tool, or the straight edge tool, for creating, you know, sides of figures or segments, things like that. That's really all you're going to need today are those three things. So if I go to point, and I'm going to create 2 points, and then I want to build a line from those points. I can hold down select and highlight things to create stuff with them, or I can do this. If I go to the selection tool, if I just put a box around everything that I want to highlight, it'll highlight it all at once, which is kind of handy. So now notice both of those points are highlighted. Where do you think I go to construct a line with those 2 points?
A line problem?
I'm going to go to the construct menu, and I'm going to choose line. Look what it does. Okay? And now look, it builds a line that's attached to those 2 points. Okay? That's going to be my fold in the paper, or my mirror. That's the line of reflection. So now it wants me to build a point not on the line. So I'll go back to the point tool, and I'll put one right there, how about? Okay? It wants me to label that point P. Well, how do I label it? I can either right-click on that, or I can go up to display, either or, and I'm going to label points. Right now, the label is A, but it wants me to call it P. So I'm going to do that. I'm going to change it to P, and you probably can't see this, but now I got a P next to it. Okay, now I want you to watch something here. This program, when I say it's intuitive, it is very intuitive. It knows how to do math. So if I want to reflect this thing, I want to reflect the point over the line. Well, I've got the point highlighted, so I should be able to do something fancy like reflect it. Which menu do you suppose I go to reflect it? My choices are File, Edit, Display, Nope, Construct, Transform, Measure. Oh, that one. Here you go, Transform. Right? Because these are called transformations, aren't they, what we talked about today? So if I go to Transform and I go Reflect, look what it does. How about that? Okay, it creates this point, and look what happens. If I just show the label, what do you think the label is going to be? P prime. It knew to call it P prime. Oh, I just made a point that I didn't want. How do I undo it? I could delete, or I could go up to Edit, Undo. And I can step backwards, right? Okay, now I've got, and look what happens here. If I grab point P and move it around, look what happens to P prime. It stays as its reflection, right? So it's a dynamic program. It's pretty cool that it does that. It wants me to construct segment P prime. How do you suppose I do that? Well, I could. Maybe I could do this. If I highlight P and I highlight P prime, if I go up to construct, I could just do segment, right? Everybody see that? Okay, and it's going to build the segment. Okay, another way I could do it is I could grab the straight edge tool and I could go down here until it becomes blue, so it's sticking to that point, click, and drag it over until that's blue and click again. And it also creates that segment. Either way, but look what it does. Okay, it's dynamic. Now it wants the intersection. Okay, I could do this. I could highlight that segment and hit Control and highlight that line, and I could construct intersection, right? Or I could also just do this. I could grab the point tool and just wait until both the lines are blue and then click down, and it creates a dynamic intersection, right? I want to label that X. So I'll go up here to Display, Label Point, and I'll call it X. Whoops. Uh-oh. I think I did some. Oh, I had them all highlighted. Whoops. I just want that one highlighted. Uh-oh. Undo. Okay, well that's X. That's supposed to be P and P prime. Whoops. But you get the idea, right? So if I call this B, now here's the last thing I want to show you. Okay, well, it says create some interesting measurements. Okay, because measurements are what's important here. Measurements a lot of times show us the relationships that we can see visually, but it actually shows us sort of mathematically that they exist. So if I want to, for example, what if I wanted to measure like this distance right here? I could highlight both of those points. I can go up to measure distance, right? And as I move the points around, the distances will change, right? If I want to measure an angle, I could maybe create a point right here. And if I want to measure this angle, how about if we show the label on that one so we know what it is? That's D. If I want to measure the angle CBD, I have to highlight the points in that order. So C, hold down Control, B, D, measure angle. Okay?
So if you were to click into the box, could you change the angle that way? The measurement box?
Good question. I don't think so. Doesn't look like I can. That's an interesting idea though. Okay, you see what I'm doing though? So you might want to make some different measurements up here. If I want to explore this reflection thing, I'm going to let you decide which measurements might be interesting, and you can measure those. But then when you're done for the day, just save the document, right, in your folder. Maybe email it to yourself at home so you have it, and you can work on it there too. Okay? Let's go to, I think it's 3:32, but let me check.